Hello mga kakalculus. So this is the second part of the integral calculus, yung pinakahihintay natin na definite integrals. So we're already halfway. Malapit na tayo mag-finals. So this is the what we call the reverse process of differential. As we remember, so in differential calculus, we started discussing limits, yung pinaka-root explanation going to the application which is maxima minima. Sa integral calculus naman, we started with the formula. We actually discussed already the formulas But this time, parang pabaliktad yung process, no? This is the time that we're going to discuss the root or yung pinagmulan ng integral calculus. So, babalikan natin ulit yung limits, yung summation notation, no? Kasi from the word integral or integrate, pinagsama-sama or duktong-duktong, no? Integrate. Kaya pag-usapan rin natin yung summation notation. So, definite integral. So, again, definite means exact. Yung value ni C or the presence of C in the equation or in the answer, tatanggalin natin yan. So, ano ba meron sa definite integral or integral calculus? So, from the word again, integral means integrate, pinagsama-sama. We have to understand first the word or what we call the summation notation. Kasi, dito nagsimula. Hindi naman agad naging calculus yan na mahirap. So, pinaka-basic ulit niyan is the four fundamental operation which are the addition, subtraction, multiplication, and division. So, let's start with the addition, no? Kasi nga, integrate, pinagsama-sama. So, if we mean summation notation, this is a symbol or notation, no? Involving a large value of numbers or mahabang pagsusulat, no, ng isang equation. So, gumagamit tayo ng summation notation to represent numbers or summation of numbers in a short possible way. So, if we say short possible way, for example, if we're going to add several numbers, let's say numbers from 1 to 10, adding it by series, let's say 1 plus 2 plus 3 plus 4, medyo mahaba-haba yun. Now, adding from 1 to 10, having an answer of 55, ay medyo maikli pa compared if you're going to add or find the sum of numbers from 1 to, let's say, 90. So, pagtsatsagaan natin yun. I-solve 1 plus 2 plus 3 and so on and so forth. So, in summation notation, like what I said, it is used in representing or getting the value of the number in a shortest possible way. So, yun yung tinatawag nating notation. No? Notating that the sum of numbers in a short possible way. Where what the notation, it is being read by the sum from I equals to 1 to n of u sub I. Now, pag sinabi kasi natin sum from I equals to 1, so that is from the start where I initially equals to 1 to n, kung saan siya papunta of u sub I. So, yung R kasi doon, yun yung numbers na ipag-add. Yung I naman, kung hanggang saan yung number, no? Again, initially from 1 hanggang saan. So, yung u sub I doon, yun yung R sub I. Yung function, ibig sabihin. Where the symbol in the summation notation is the Greek capital letter known as the sigma. So, hindi na kasi natin ginagamit nowadays, no? Yung mga Greek capital letters or Greek alphabet na yan, which is the same in the English alphabet S for sum. So, ngayon na lang kasi nagkaroon ng letter na S. Dati kasi ang S, yun yung sigma kung tawagin. So, ginagamit natin yan in the old way na dala-dala ngayon hanggang sa present in mathematics. Kaya yung symbol ng integral calculus, as we notice, na elongated S siya, in relation with the word sum, summa, or in Greek capital letters, sigma. Okay? So, yung I naman is just the summation index used as a dummy subscript. Siya yung nagde-denote kung sino yung una, pangalawa, pangatlo, pangapat, panglima, and so on and so forth. So, in summation notation, we have also different formulas. Hindi kasi natin pwedeng isolve nga ng mahaba. Yung summation notation, ginagamit para mapaikli ang isang mahabang sulatin sa mathematics na yung pagsosolve. So, ano yung mga formulas na yan? Let's say we have the summation of I, where I initially from 1 to n. So, instead of writing series of numbers, so gagamitin na lang natin daw yung formula na n times the quantity n plus 1 divided by 2. No, yung n, yan yung pinakadulo ni I kung saan siya pupunta. No, initially from 1 according to that. Pero kahit saan naman pwede siya, no, I is equals to 2, it means nagsimula sa 2, tapos n is equals to 5, it means 2 to 5. Okay, what if we have the square of the number to be added? So, parang multiply nyo lang yung summation of I times summation of I. Or sa I squared, summation of I squared is equals to n times the two quantities. The first quantity is n plus 1 and the second quantity is 2n plus 1 divided by 6. So, hindi nyo naman kailangan i-memorize siya, no? Just applying yung summation formula nung una, formula 1, parang in-square mo lang or i-multiply mo by itself. So, arriving at the same formula as the summation of I squared. Okay, yung I cube, just multiply yung formula 1 and formula number 2. So, yun yung mangyayari naman. Okay, so you have to memorize it also, pero hindi yan kasi ang pinaka-focus natin sa integral calculus. We have formulas in integral calculus. If I'm not mistaken, we have already 20. We have discussed 20 formulas. So, yung pinag-uusapan natin ngayon na summation formula is just the explanation para magamit natin mamaya yung integral formula. Paano ba nagkaroon ng integral formula? So, if we have the summation of k, where k is constant, anong ibig sabihin lang nito? No, so, yung k inilalabas lang. No, wala tayong i-apply actually na formula except that k is being multiplied by the n. No, kung saan yung pinakahangganan ni I. Okay, but if we have the product of a constant and a function, let's say k is a constant, yung r naman sub I, so may subscript siya, no, or dummy na I, hindi natin alam kung hanggang saan yung I na yon. So, si k, parang nilalabas lang siya sa summation, hindi na siya ini-involve. And we're going to evaluate the summation of R. Yung summation of R, pwede siya yung summation of I, yung formula 1, formula 2, formula 3, no, and so on and so forth. And lastly, if we have two function, getting the summation of two function, add, addition, or subtraction, so pinaghihiwalay lang rin yun. We can parang distribute the summation notation para sa function R and to the function of T. Okay, so sana naintindihan. Now, basic lang naman siya. So, let's have an example. Find the value of the following. Let's say number 1. Okay, find the summation of I, where I initially from 1 to n, where n is equals to 3. So, it says in the problem, where I is equals to 1 to 3. So, paano daw i-add yun? So, if we're going to solve that manually or in the long method or conventional way, that the summation of I from 1 to 3 is equals to, yan, I sub 1 plus I sub 2 plus I sub 3. No, kasi nga, initially from 1 to n, where n is equals to 3. So, initially, that my I sub 1 is 1, no, plus 2, plus 3. So, we come up with the answer of 6. So, yan yung long method. No? Imagine niyo kung yung n ay 90. So, 1 plus 2 plus 3 plus 4 hanggang umabot ng 90. So, hindi nyo isusulat ng ganun yon. Now, you're going to write it the summation of I, where I is equals to 1, to n, where n is equals to 90. So, if you're going to solve that using the summation notation, so regardless kung hanggang saan na siya ha, so we're going to apply the formula. Ano yung formula number 1? Where the summation of I from 1 to n is equals to n times the quantity of n plus 1 divided by 2. So let's try solving the problem number 1 using the summation formula. So since n is equals to 3, so we have 3 times the quantity of 3 plus 1, which is 4, times 3, which is 12, divided by 2. So we're going to come up with the same answer of 6. So, mas madali. So, kaya, kailangan natin i-memorize yan. So, let's proceed sa example number 2. Okay, what is the summation of the quantity 6i plus 3 where n is equals to 4? So, by understanding that the summation problem is the summation or adding the two functions. And according to the last formula a while ago of the summation notation formula, adding two functions, we can separate the functions. Now we have the summation of 6i plus the summation of 3. But if we're going to show it in manually or yung conventional way, na yung I papalitan natin from 1 hanggang 4. Kaya 6 times 1 plus 3, so that's the first group, plus 6 times 2 plus 3, which is the second, hanggang umabot daw sa fourth group. So, ang pinapalitan natin doon si I. So, take note of that. Ang pinapalitan natin, sulatan ko lang. Si I, ito si I eh. Si I yan. According sa problem, 6i plus 3. So, I sub 1, this is I sub 2, I sub 3, and I sub 4. Okay, so if we're going to sum it up, we're going to have an answer of 72. So, again, by using the summation notation, so like what I said, adding two functions in the summation notation, we can separate the two functions. We have the summation of 6i plus the summation of 3. And by looking on the first part, itong part na to, we can apply the formula of the product of a constant and a function. So sabi natin, yung constant in the function, si 6, pwedeng ilabas to si 6. Now, parang magiging 6 na lang siya times the summation of I. Okay, so ganun yung mangyayari. Okay, so let's see. Ayan. Tapos, yung second term naman, summation of a constant, where 3 is a constant, so 3 times the n kung saan siya pupunta. So, if we're going to evaluate or using the summation of I on the first term, so katulad kanina yan, no? N times n plus 1 divided by 2. Okay, so apply natin yon, plus 3n, where n, according to the problem, is equals to 4. So, we have 6 times 4 times the quantity of 4 plus 1 divided by 2, where the second term is 3 times n or 3 times 4. So, if we're going to compute that, we're going to arrive at the same answer, which is equals to 72. So, kung sasabihin niyo, sir, mas madali pa yata yung first o yung conventional solution. Yes, in that case, pero paano kung ang n mo ay equals again sa 90? Pagtsatsagaan mo ba na 6 times 1 plus 3, 6 times 2 plus 3, hanggang umabot sa 6 times 90 plus 3? So, kukulangin na yung oras ninyo. So, it's a better way or the better method in solving that kind of problem is using this summation notation formula. Okay, so I hope naintindihan yan. Hindi tayo dyan magka-focus, no? So, yan yung introduction ng integral calculus. So, moving forward. So, the best way to explain integral calculus is by means of illustration. So, class, yung application kasi ng integral calculus, mas ma-appreciate yan in using in areas. Kasi yun naman talaga rin ang pag-uusapan natin. Area, centroids, volume, centroids. So, yun yung pag-uusapan nating application eh. So, medyo papahagingan ko na sa inyo ngayon or we're going to start in advance the discussion of area but hindi muna tayo magpo-focus doon talaga, no? Mas mabilis or mas madali nyong maintindihan kung ma-explain ko sa inyo in a form of illustration by showing the area. So, on this figure, we have the Cartesian coordinate. Now, we have the y-axis and the x-axis. Y-axis and the x-axis. So, ano meron ngayon sa figure sa x and y-axis? So, meron tayong given na equation or function where y is equals to f of x. Nung dinrawing natin yan, okay, ito na yung graph. So, take note nung dinrawing. So, it means, sa pag-uusapan natin ngayon sa definite integrals, kailangan marunong kayong mag-graph. So, ayun na yung sinasabi ko sa inyo. Kailangan may background kayo sa analytic geometry. Ano meron sa analytic geometry? Equation ni lines, equation ni circle, equation ni parabola, ni ellipse, ni hyperbola. So, kailangan familiar kayo doon. Kasi hindi ko na rin ituturo sa inyo yon. You have to study about the different conic sections, equations ng line, kasi napaka-importante yon. Okay? So, continuing. So, on the equation, let's say yung equation na yun, kasi pinutol ko lang, no? Kasi, what if the equation, no, tuloy-tuloy yung graph na yan, pataas. Pero, I want to solve or to get the area bounded or yung nasasakupan lang nitong A at nitong B. So, yung part na yan. So, it means itong part lang na to. Paano kung yan ang gusto kong kuning area? Okay. So, nagigets ba yung sinasabi ko? Okay, so wait lang. Okay, so let's continue. So, lahat ng kasi. Finding the area of a region R by the x-axis on the sides by the line x equals to A. So, parang ito yung x equals to A ko hanggang x is equals to B. And above by a curve y is equals to the function where f is the continuous on A and B. So, yung graph kasi, yung function, pwedeng putol yan sa taas or putol sa baba. Sabi natin sa differential calculus, di ba? You can only get the derivative of a function if the function is continuous. So, pwedeng discontinuous to sa taas or sa baba, but from A to B, no, yung simula at hangganan ni x, continuous siya. Okay, so, ayun daw hahanapin yung area na yan. So, paano daw mangyayari? Okay, so, what we did, or what we're going to do, in getting for that area, kasi hindi naman siya specific yung curve, no, yung pinaka, no, pag sinabi ko, ano itsura nito? Wala kasi tayong gantong shape, or pag dinrawing ko yan, pag ganyan, wala tayong ganyang pinaka-figure na formula. So, para makuha natin yung area niyan, yan tinatawag nating chop-chop method. So, paano chop-chop method? Subdividing the interval from A, so dito tayo simula, okay, to B. Okay, ibig sabihin, si A and B, mga values siya ni X, where X is greater than equals to A, kasi going to the right tayo, but less than equals to B. Subdividing the interval into n sub-interval by means of the point x sub 1, x sub 2, x sub 3. Ano ibig sabihin? Gagawa ako ngayon ng rectangle. The first rectangle ito. second rectangle ito, third rectangle ito, and so on and so forth. So, bawat rectangle, meron tayong value ni x. Okay, so let's say ito yung x sub 0, not this is n, this is 0. X sub 0, x sub 1 ito, x sub 2 ito, x sub 3, and so on and so forth. So, yung pinakadulo niya is x sub n. Yung pinakasimula, x sub 0. So, bago magdulo is x sub n minus 1. Okay, so may mga rectangle tayong nabuo. So, again, subdividing the interval into n sub-interval by means of the points x sub 1, x sub 2, and not necessarily equal in lengths, producing the number of rectangular strips. So, ano yung sinasabing not necessarily equal in lengths? So, on this rectangle, so meron siyang uniform na height. Ito, nilagay ko na lang sa gitna. Ito kasi yung tumatama doon sa curve. Okay, sa rectangle naman na to, meron tayong doon yung tumatama. So, yung mga tumatama na yan, na pataas, or length, we're going to name that C sub 1, C sub 2, C sub 3, and C sub 4. So, ibig sabihin, yung mga Z na length is the value between the two x. No, ay si x sub 0 at si x sub 1, sa gitna niya ay si C sub 1. Si x sub 1 at saka si x sub 2, ang sa gitna niya ay si sub 2. So, para siya yung average. Kapag in-add ko yung x sub 1, x sub 0, okay, kasi si x sub 1 hanggang dito lang eh. Yes, sulat ko lang. So, si x sub 1 kasi, ito lang siya actually. Yan lang yung height na yan. Si x sub 0 to, ano? Si x sub 1 ito mas mataas. So, yung dalawa kasi na yan, rectangle yan eh. So, parang yung average kinuha ko ito. Ito kasi yung tumama sa curve. Ginawa kong C sub 1. So, kung ito naman si x sub 1, ito naman, mas malaki naman si x sub 2. So, ang kukunin ko yung rectangle lang na to. So, pinaka-average niya ito. Ginawa ko naman siyang C sub 2. Okay, so nakakasunod. Okay, good. So, it means that my x sub 0 is equals to A. Okay, si A yun, sa x sub 0, which is less than. Mas maliit si x sub 0, of course, kay C sub 1. Na mas malaki naman si x sub 1 kaysa kay C sub 1. Na mas malaki si C sub 2 kaysa x sub 1. Na mas malaki si x sub 2 kay C sub 2. And so on and so forth. At ang pinakahangganan nila, ang dulo nila, ay si x sub n, which is equals to B. So, nagsimula kay A hanggang kay B, where A is equals to x sub 0 and B is equals to x sub n. Okay? Do you follow? Sana nakakasunod pa rin, no? Where delta x sub 1 is equals to x sub 1 minus x sub 0. Okay, so ano ibig sabihin nun? Si x sub 1, delta x sub 1 ba? Delta means difference. Difference siya ng ano? So, kung i-isolate ko lang itong dalawang to, ano, yan, triangle na yan. So, ito kasi si x sub 0 yung height. Ito si x sub 1. Ngayon, kung kukunin ko yung difference ng dalawa, yan si delta x. So, it means delta x. Okay, kasi maraming delta x eh. Delta x. Bawat rectangle may kanya-kanyang delta x. So, hindi magkakasukat, magkakataas, magkakalapad ang bawat rectangle. Kaya, lalagyan ko ng subscript, x sub I, or delta x sub 1, delta x sub 2, delta x sub 3, and so on and so forth. Okay? So, since pinag-uusapan natin is the first rectangle, kaya delta x sub 1. Okay, wait, delta x sub 1 siya. So, if we're going to get yung lapad niya or yung distance, so we need to subtract x sub 1 minus x sub 0. Kung kay delta x sub 2 naman, dito na tayo. para naman sa difference sa x sub 2 yan, minus x sub 1. So, ayun yung ibig sabihin kanina nito, ano? Is 1. Okay? So, next, we have, oops, burahin ko lang muna. Okay, so nabura ko na siya. So, anong gagawin ngayon natin dito? So, adding all the areas of rectangular strips. Ang kinukuha kasi natin yung area, no? Again, lilinawin ko lang, ang kinukuha natin yung area. Oops, wait. Yung area na to, no, from A, yung area na yan, hanggang B. Siyempre, kasama tong x-axis na yan, no? Ayan, sorry. Mali pa, drawing ko yan. Ayan. So, kung kukunin ko yan, gumawa ako ng mga rectangles na chinap-chop method ko. Siyempre, hindi pa rin may iwasan naman dyan yung may mga sumusobra. Yan, sobra, may mga sobra. Sa bawat rectangle, may mga sobra, of course. So, mamaya, explain natin kung anong gagawin dyan sa sobra. So, adding all the areas of rectangle strips inscribed in the region where the different lengths are represented by z's. Ayan na yan, yung pinakagitna, no, ng dalawang x. And the widths are represented by delta x. So, since area pinag-uusapan, ibig sabihin, i-add ko lahat ng mga rectangle, area ng rectangles. So, parang makukuha ko na yung kabuuan ng shape. Pero, may mga sobra nga, no? But still, kahit papano, nakuha na natin yung area, no? May mga sobra, may mga kulang, no? May mga kulang, may mga sobra. So, yung mga sobra at kulang, saka natin explain anong mangyayari doon. Pero, so far, pag kinuha ko yung total area o lahat ng area ng bawat isang rectangle, halos makukuha ko na rin yung kabuuan ng area na gusto natin kunin. Okay, so paano ba pagkuha ng formula ng area ng rectangle? So we have length times the width. So sa area 1, dito sa area number 1 ng rectangle, area 1 ng rectangle, this one. So meron akong length, which is represented by C sub 1. Okay, times the width, no, delta x sub 1. So, ito yun. Okay, for area 1. For area 2, ganun din. Length times width, but this time, we have a subscript of 2. Area 3, C sub 3, and delta x sub 3, and so on and so forth. Kung ilan yung rectangle na binuo natin doon, ganun din kadaming area yung kukunin. So, anong gusto kong explain? What I'm trying to explain. Okay, applying the summation notation. Kasi hindi natin alam kung ilan ang rectangles na mabubuo. Mas marami, mas maganda. Bakit ko nasabi yun? Sige, explain din natin mamaya yun, no? We're going to apply the summation notation. It means that the total area, instead daw na area 1 length times width, area 2 length times width, isa-isahin, gawin na lang natin yung pinaka-formula. No, this is fc sub I. This is the length. No, ayan yung c sub I, no, length. Yung delta x, this is the width. So, kukunin natin yung summation notation ng bawat isang area. So, gumamit tayo dyan. Ang tawag ngayon natin sa process na yan is what we call the Riemann Sum. So, sino ba si Riemann Sum? Okay, doon sa may mga book na may hawak, I write it down that George Friedrich Bernard Riemann, born 1826, died on 1866, which is a German mathematician who developed a system of geometry that aided the development of modern theoretical physics. So, siya yung nagsabing pwedeng i-apply ng Riemann sum yung mga bagay na masyadong mahaba. At gamit na gamit yan sa physics o sa modern physics. Now, in letting the number of subdivision n increases in such a way that delta x approaches to 0. So, ano ibig sabihin? So, lilinisin ko lang muna itong sinulat ko kanina. Ayan. So, ang ibig sabihin nito, kung dadamihan ko daw, kasi yan, ito malaki to, di ba? Malaki yan. So, kung dadamihan ko daw yung mga rectangles ko, bakit dadamihan? Where delta x approaches to 0, ibig sabihin, liliit dapat itong delta x. So, paano liliit yan? Dadamihan ko. So, yung delta x sub 1, na-subdivide pa siya ng marami, no? Ganyang kaliliit na lang. Oops, maliliit. Kung dadamihin ko pa, ano nangyayari kay delta x? Papunta na siya kay 0. No? Pero dumami ngayon yung area ko. So, wala namang problema sa pagdami ng area kasi pwede natin gamitan ng Riemann Sum. So, ano daw mangyayari? As a result, that the sum of the Riemann Sum approaches a limit which does not depend on the mode of division and denoting this limit by. So, yung Riemann Sum daw, pag in-applyan ng limits, ano yung limits? Si delta x daw, paliliitin. Yung width, papuntang 0. It means pinarami yung rectangle natin. So, ang sabi natin, pag ang isang bagay ay in-applyan ng limits, siya ay nagiging calculus. Yan na yung tinatawag nating integral calculus. So, it is being read that the integral of f of x dx from a to b. Ano yung a to b? Okay, yan yung simula at hangganan. No? So, again, f of x dx, integrand, yan yung sinusolve natin before. Yung a ngayon is what we call the lower limit. And b is the upper limit. Or in short, that both a and b are the range of integration. So, kasi nga, gusto natin kunin yung area mula, no? Ito yung ano natin ito yung pinaka-graph. Continuous dapat siya. Continuous from A to B. So, gusto natin kunin ngayon yung area from A to B. No? Kasama yung x-axis, no? Yung area na yan. So, habang pinaparami ko yung rectangle, na pinipino mo, kung parang giniling No, mapapansin ninyo, kumukonti na lang yung sumusobra at halos natatakpan na yung nababakante. So, mas maraming rectangle, it means lumiliit yung delta x, mas nagiging accurate yung pagkuha natin ng isang area ng isang bagay. Dahil yon doon sa limits. So, ano yung limits? Where delta x approaches 0. Okay, so sana naintindihan yung part na yun, no? Okay, so balik tayo ngayon. Since that delta x approaches to 0, okay, so tanggalin muna natin ulit yung drawing. So, since delta x approaches to 0, okay, lumiliit na yung distance niya. It means that the number of rectangular strips increases indefinitely. Of course, kaya nga lumiliit yung length or yung width pala kasi dumadami ngayon yung rectangle. Pag dumarami yung rectangle, lumiliit ulit o papunta sa 0 yung delta x. So, ano nangyayari? Halos magkaka-shape na siya. No, hindi katulad nitong una. Okay, ano yung una? Magkakaiba to ng rectangle. Sa rectangle 1 is different from rectangle 2, rectangle 3. Magkakaiba sila. Nung may payat, may mahaba, may mataas. Pero kung padadamihin daw nga natin yung bawat rectangle, halos nagiging magkamukha na siya. So, kung wala nang pinagkaiba, it means hindi ko na kailangan pa ng subscript I kay delta x. That delta x is now equals to delta x of 1 plus delta x of 2, delta x of 3 kasi in-applyan na natin ang limits. Therefore, instead of writing down limits of delta x approaches to 0, ito kasi yung kanina, no? Delta x of I approaches to 0. So, we're going to replace that as n approaches infinity. No, para mas magamit natin ng mas maayos yung integral calculus. The summation of the what? Area. So, ano ulit yung area? Yung area, yung fc sub I, this is the length. Delta x is the width. No, area for the rectangle. Summation, yung length 1, width 1, plus length 2, width 2 ng bawat rectangle. Mas maraming rectangle, where n approaches infinity, 1 to sawang rectangle, mas nakukuha natin ng accurate yung shape o yung area ng shape na gusto nating kunin. So, ayun lang yung pinaka-explanation niya. Where yung delta x, which is the width, is equals to b minus a divided by n. No, kung ano yung pinakalapad niya, no, from this part hanggang dyan. Okay, gano'n daw kalapad, depende kung ilang rectangle yung gagawin. So, ayun yung width, tama naman. And our c sub I, no, ito yung pinaka-length, yung sa gitna, nakukunin natin kada rectangle is equals to a plus I delta x. So, yun yung magiging pinaka-formula ngayon natin. So, let's have an example. Okay, nasusundan ha. So, let's have an example. Find the area under the line y is equals to x over the interval. Actually, it's called closed interval. Why closed interval? Kasi yung symbol na to ay para sa close. No? Pag parenthesis, open. Napag-aralan nyo yan dapat. So again, over the closed interval, kasi continuous nga yung graph. No? Continuous tong function na to. Yung function na yan, where y is equals to f of x, is continuous from a to b. So, kaya tawag closed interval, nasasakupan yan. Find the area under the line y is equals to x. So, ito ngayon ang problema. Sabi ko sa inyo, dapat marunong kayong mag-graph. Ano yung equation ng y is equals to x? Pag nilagay ko yan sa Cartesian coordinate system, ano itsura niyan pag dinrawing? So, that actually is a line. Line na ano? Pwedeng patayo. No, pwedeng patayo yung line. Pwedeng pa-horizontal. Or pwedeng pa-incline. So, paano malalaman kung patayo, pa-horizontal, pa-incline? So, since present both y is equals to x, no, by general equation of the line, ax plus by plus c equals to 0. Kung natatandaan nyo yan. So, kung walang by or walang y, ax plus c lang, for c is a constant equals to 0, ang line niya ay pa-vertical. No? So, wala kang makikitang y. If I have just by plus c equals to 0, ang line niya pa-horizontal. So, if present both x and y, so yung equation ng line mo naka-incline, pwedeng to the left, or to the right, or to the right to the left. Depende yun, ha? So, paano ngayon lalo to? Y is equals to x. So, kung iaayos ko ito based dito sa general form, so si y ang ililipat ko sa kabila. X minus y is equals to 0. So, ax ko, ang a ko ay 1, ang b ko ay 1, ang c ko ay 0 kasi wala namang nakalagay. So, ano ibig sabihin? Pag c ay 0, Pag walang constant, ibig sabihin yung line ay dumaan sa origin. Ito yung origin. So, dyan dumaan daw yung line. Ayan, dyan dadaan yung line. So, hindi naman pwedeng vertical yan or horizontal. So, again, present both x and y. Now, dalawa na lang pagpipilian ko. Incline to the right ba o incline to the left? No, by looking again on the equation y is equals to x. So, based on the slope-intercept formula, di ba? Slope is your y. Pag positive daw ang slope or yung y, incline to the right. Pag negative daw ang y or ang slope, incline to the left. So, based on the problem that y is equals to x, it means, okay, walang constant. The line will pass through the origin. Ang y, ang slope, positive, it means inclined to the right. So, ayun lang yung ibig sabihin nun. So, if that is the case, we can now draw the line. Ayan. Tapos, over the interval daw of 1 and 2. So, ito yung 0, which is the x-axis. Yung 0, ano? Ito yung x-axis. Interval from 1 to 2. So, ito yung part lang na kukunin natin. No? So, yan yung part na kukunin natin. Ano yung area na yan? Paano natin isosolve? Okay, so gagamitan natin ng yung formula ni Riemann Sum, applying the limits. Okay, so let's continue. Okay, continuing on the problem. Okay, we're going to draw a rectangles. So, dito sa sample ko, ginawa ko lang na 3. Pero sabi nga, di ba, sa limits, yung 3 na yan, magkaka-equal na yan, no? Kung mas paparamihin pa daw natin, kasi apply na nga ng limits, hindi ko na lang pinakita dito. Kung mas paparamihin ko pa yung rectangles ko na mas pinong-pino, mas maganda. Where n approaches infinity. Ayun ang ibig sabihin. So, okay, so for the meantime, yan muna yung dinrawing ko para lang mas ma-visualize, no? Okay, so ito ngayon yung hinahanap ngayon natin. Okay, so babalik ko lang ulit. So, hindi kasama yung taas, kasi kaya lang naman nagkaroon ng sobra, no? Kaya lang naman nagkaroon ng sobra. May sobra dito. Kasi, hindi pino yung rectangle at 3 piraso lang. Pero kung mas marami yan, mas kukonte or halos mawawala na yung sobra kasi bawat delta x magiging approaches to 0 or 0, mawawala na siya. Okay, so again, ihiwalay ko yung gusto natin kuning area. So, anong shape ba yung hinahanap natin? Okay, yung shape na yan, yan yung trapezoid. So, kung natatandaan ninyo, ano ba formula ng trapezoid? Okay, so at first, labelan muna natin, ha? So, sa label ng trapezoid, we have 1 and equals to 2. Or, sorry, from 1 to 2. Yan yung limits natin. Yung lower and upper limit. So, ito yung formula, area. Area ng trapezoid. Yung kung gagamitan lang natin to ng formula, no? Kasi may shape naman ng ganyan, eh. We have 1/2 times base 1 plus base 2 times the height. Okay, nasusundan ba? Hihiga ko lang siya, ha? Kung ito ay hihiga ko, para mas madali nating masolve. Oops, sorry. Ayan. Ito kasi okay, yung first height ko, ito yung 1, eh. So, So, yung hiniga ko, ito na yung 1. Okay, tapos ito yung 2. Tapos, ano ba pagitan ng 1 and 2? From 1 to 2, meron akong 1. Ayan, yung height. So, this is my B1. This is my B2. And this is my height. So, based on the formula, if we're going to use by formula, 1 half, B1 is 1, plus B2 is 2, times height of 1. So, we have 3 over 2 square unit. So, huwag kakalimutan lagi ang unit. Pag walang unit, lagyan ng unit. So, square unit siya, o unit square. So, ganyan lang actually siya kadali kasi known yung shape. Kaya lahat ng shape actually ng polygon, walang pangalan kung sino naka-imbento. Kasi nga, hindi pwedeng angkinin dahil nanggaling yan sa calculus. So, if we're going to solve that using calculus, so ito na. So, if we're going to solve that using calculus, so kailangan natin sundin yung pinaka-formula kanina. Okay, so solution tayo. So, we have y is equals to your function. Okay, dyan tayo nagsimula, no? Which is also equals to the Riemann sum. Okay, so gagamit muna tayo ng Riemann sum, hindi muna tayo gagamit ng calculus. So, apply ko na rin muna yung limits. Sabi kasi yung limits as n approaches infinity. Applying limits on the Riemann sum. Initially, okay, ito yun na yung lower limit. Lower limit from 1, ito yung a kanina, to b. Okay, from 1 to n. Kung ilang rectangle daw yung gagawin. Depende. Hindi siya yung b, yung n, kung ilang rectangle yung gagamitin. Times yung fc sub I, which is the length, times the width, or delta x. Kung natatandaan nyo yan. Nung in-apply yan sa Riemann sum ng limits, yan na yung naging integral from a to b of x dx. Ayan. Kasi sa x tayo nagpa-focus ngayon, no? Nandoon kasi yung pinaka-limits niya. Okay, nakakasunod? Okay, so focus lang muna tayo sa Riemann sum. Ito lang. So, kailangan natin kunin si delta x at si fc sub I. So, solving for delta x. Okay, ano yung formula natin ng delta x? The formula of our delta x is b minus a over n. So, ano ba yung value ni b? We have 2 minus a, which is 1 over n. Hindi natin alam kung ilan beses natin nahatiin. Pinakita ko lang sa figure yung tatlo pero dapat yan mas marami, mas maganda. Approaches to infinity, no, according sa limits. Hindi naman natin alam kung hanggang ilan ano ang dulo ng walang hanggan. Ang calculus lang, tayo lang mga engineers ang may forever. No, infinity kasi yan. So, in short, that my delta x is equals to 1 over n. Okay, so standby muna tayo kay delta x. Next, how about for fc sub I? So, according sa formula, c sub I pala, sorry. Hindi mo na. C sub I. Kasi function, pinagsama-sama na. C sub I muna tayo. C sub I is equals to a plus b plus I pala, sorry, a plus I delta x. Ayan. So, yung a natin, siya si 1 plus I delta x. Delta x, we already solved it, which is 1 over n. Okay, so nakakasunod ba? Okay, so sana nasusundan So, this is my c sub I. Okay na. So now we can solve for the Riemann sum, applying limits. That the limits of the Riemann sum where I from 1 to n, di natin alam kung ilan ang magiging rectangle niya, of c sub I delta x, where n approaches infinity is equals to, okay, so paano natin i-evaluate? So, limits, okay, class dito ko na lang susulat para mas maganda yung space natin. Limits, n approaches infinity of the summation from 1 to n. Okay, ano yung magiging function ngayon natin? Yung fc sub I is 1 plus I over n. Okay, pinasok ko lang ito sa loob ha. Ito pinasok ko lang sa loob. Okay, I times 1. Kaya I over n na lang. Times delta x, where delta x is 1 over n. Ayan na yung pinaka-equation natin. Okay, hindi muna tayo nag-integral calculus ha. Okay, Riemann sum lang tayo. So, simplify muna natin. So, limits of the summation. So, if we're going to multiply it, napapasok natin ito, multiply kay 1. So, we have 1 over n plus, okay, so ito ulit, multiply dito. So, we have I times 1 is I. Tapos, n times n is n squared. Okay, do you follow? Nasusundan ba? Okay, good. Nakakasunod. Okay, so ang sabi natin sa limit, sa formula, okay, sulat ko lang itong I. Sa summation notation, okay, dalawa na iintindihin nyo ha. Summation notation, may formula, yung limits, na-discuss na natin yan nung differential calculus. So, if we're going to apply first yung summation notation, yung limits, mamaya na natin i-evaluate. So, kailangan memorize nyo pa rin yung limits natin sa differential calculus o limits. So, sabi natin summation notation formula, pwedeng paghiwalay ng addition. So, summation of 1 over n plus summation of 1 over n squared. Yan. Yan, dalawa na yan. Mamaya, i-evaluate natin yan bago i-apply yung limits. Okay, so yung limits nasa labas. Limits. Mamaya na natin i-evaluate yan. Standby muna. So, class, ano ba yung n dito? So, constant yan. So, ano sabi natin doon sa constant? If we have a constant, so, paano ina-apply yung constant? Minumultiply lang rin sa n. So, kung n na yung constant, multiply ko lang kay n. Okay, nasusundan? Okay, dito may I ito ha. Okay, tapos, sa part naman dito, para hindi kayo malito, ito kasi, so baka sabihin nyo, sir, saan nanggaling yan? Isusulat ko lang dito. Pwede kasing gawin natin, I kasi to, ano, I. Pwedeng I times 1 over n squared. And, so, yung 1 over n squared constant, pwede ko nang ilabas. According sa law na according sa formula ng summation notation. So, yung 1 over n squared, pwede ko nang ilabas. May matitira pa sa loob na I. Where I from 1 to n. Okay, so yung first term, wala nang summation notation. Yung second term, meron pa rin. So, let's continue. So, limits. Standby ka muna dyan. Mamaya ka na namin gagamitin. Okay, so n times n. Ang sagot, we have n squared. Sorry, 1 over n pala to. Nagkamali ako. So, cancel na pala to. 1 over n yan. So, 1 na lang yan. Hindi magiging n squared plus 1 over n squared. Okay, ano yung formula ng summation of I? Diba, ang formula, okay, times ko lang ha. Times yung formula is n plus 1 over 2. Ayan yung formula kanina. Okay, so evaluate muna natin yung nasa loob bago i-apply yung limits. So, we have 1 plus, okay, yung n sa labas at n squared sa ilalim. Okay, mababawasan na yung isa sa ilalim. Ang matitira na lang sa taas, mayroon pa akong n plus 1. Divided by, may 2 at yung natirang isang n. Okay, nakakasunod ba? Okay, nasusundan ba? Okay, so kung nakasusundan, very good. Kung hindi, try to analyze the problem. Hindi pa natin ina-apply yung limits. Okay, now, apply na ngayon natin yung limits. So, sabi naman sa rule ng limits, apply na natin itong limits ha. Sa addition, pwedeng ihiwalay ang limits na paghiwalayin. So, we have limits of 1 plus limits of n plus 1 over 2n. Okay, both n approaches infinity. Tapos na tayo kanina sa summation notation, limits na lang. Equals, what is the limits of a constant where n approaches infinity? Pag walang kinalaman si 1 kay n, the answer is still the constant. Okay, 1 plus. Okay, paano ngayon natin i-evaluate itong limits na to? Okay, so isip. Pwede nating paghiwalayin muna yung nasa loob. Limits. Okay, paghiwalayin muna natin yung n na una, divide ko ng 2n plus 1 over 2n. So, parang kinuha ko muna yung LCD. Where n approaches infinity equals 1 plus limits where n approaches infinity. So, yung n cancel na. Meron na lang akong 1/2 plus 1 over 2n pa rin siya. Okay, continue answering 1 plus, okay, yung limits, pwede na naman nating i-distribute kay 1/2 at kay 1 over 2n. So, we have limits of 1/2 plus limits of 1 over 2n where n approaches infinity. Okay, so for the meantime, ihiwalay ko muna kay 1 ha, para hindi kayo malito. So, pwedeng lagyan, pwedeng hindi, para lang makapag-focus tayo. So, we have 1 plus, so what is the limits of 1/2? So, again, 1/2, itong 1/2 na to, constant lang rin yan, walang kinalaman kay n. Still, the answer is 1/2. So, natanggal na natin yung limits. Plus, okay, ito, 1/2n. May n sa ilalim. Anong sabi daw kay n? Si n daw ay papunta kay infinity. So, kung si infinity ay walang katapusan, imumultiply ko ngayon kay 2, parang sinabi mong 2 times sobrang laking value, mas lalong lumaki yung value. So, infinity pa rin. So, pag ang denominator o yung nasa ilalim ay sobrang laki kumpara sa numerator, so parang 0. Parang sinabing 1 divided by so many. May isa kang candy, pinaghati-hati-hati mo, so halos wala ka nang matitikman doon. Kaya 0. So, wala na to. So, 1 plus 1/2 ang mangyayari. And 1 and 1/2, we have 3/2. So, yan 3/2 is now our area. So, lalagyan ko na siya ng square unit kasi area siya. Kaya square. So, same answer doon. Okay? So, nasusundan ba? So, I hope nasusundan nyo. Tapos, more formulas din tayo and examples, pero hindi na dito dahil sobrang haba na naman. So, sa may mga book, please study. No? So, advantage na kasi yon, may libro na kayo. So, para magbasa-basa na lang kayo. So, again, for those who have not yet subscribed, kindly subscribe, like, hit the bell, and of course, share para may matutunan yung iba. So, mag-start na rin tayo ng reporting. So, that's it. Thank you for your time, for watching. Goodbye and God bless us all.